This week on Maker Update, on a wing and a prayer, making your own RAM in a shed, corrugated starships, and indestructible PLA parts. Hello and welcome back to Maker Update, our weekly showcase of our favorite Maker projects, tips, and tools from across the internet. I'm Tyler Weingartner and I hope you're all doing great. I'm excited to get into this show, so let's get started with the project of the week. At some point, you've probably played with one of these toy gliders that uses a large rubber band to store energy for the propeller. If you haven't, they're pretty simple. You spin the propeller to twist up the rubber band, then just give it a gentle toss as the rubber band unwinds to spin the propeller, giving it a short bit of thrust. Tom Stanton is creating a new take on this classic toy, but he's using a supercapacitor to store the energy instead. Building a plane as light as possible is the name of the game here. Instead of balsa wood, he's 3D printing the wings. The printed plastic is heavier than the wood, but it's also stronger, and it's less tedious to work with. The membrane of the wing is made from tissue paper, and he's able to print directly onto the tissue and then trim off the excess. He can use a heat gun to form the wing into an airfoil shape. To charge the plane, I suppose you could probably spin the propeller, forcing the DC motor to act as a generator. But instead, he's using a hand-cranked generator that can get the capacitor charged up to 3 volts in just a few seconds. He can then plug in the motor, give it a toss, and the plane can stay in flight longer than any traditional rubber band plane ever could. A huge amount of the work in this video is finding the right shape of the wings, and you get to learn some fun terminology here. He first began with a shape that almost resembles a parachute. It flies well enough, but the wing shape can create small vortices that can force the plane into a nosedive. He's limited somewhat in size by the bed of his printer, but he was able to print the final wing shape in 2 halves, and then weld the 2 halves together later. The air pressure forces the tips of these slimmer wings up pretty dramatically, but that's okay, since it produces a more stable flight. It's a fun idea for a project, and the tissue paper wings hold up surprisingly well, as long as it isn't a foggy day, like this one. The paper just absorbs too much moisture. Tom shares all of his 3D print files for you to make your own, and also includes the BOM for the motor and capacitor choice. Check it out. More projects. No matter who you are, you've probably heard of the global RAM shortage and the resulting skyrocketing prices. Part of the problem is that there are only 3 manufacturers of RAM, but now there's a 4th. Dr. Semiconductor has turned his shed into a clean room and a small-scale chip fab to see if he can make his own RAM. You get to see the entire chip fab process here. Breaking down the wafer, placing it in a 2000-degree furnace to oxidize it, coating the wafer, adding the photoresist. He's using a projector that looks like a microscope to project the UV light image of his circuit design onto the wafer to selectively burn off the photoresist layer. He's painstakingly building and removing layers of oxide to form the basic building blocks of a RAM chip, transistors and capacitors. He's able to check his work using these extremely tiny probes to apply voltage into the circuit, and as long as he's not using too much voltage, it all works properly. From here, he just needs to scale up the process before he's able to connect it to a PC, but that's the next step. Stay tuned. From 3D Printer Academy, we have a video on how he's created this entirely 3D printed modular pinball table. And just to raise the stakes a little bit for himself, he has 2 rules for this project. Everything must be 3D printed and no electronics. Everything has to be mechanical. He's experimented with a few different printed springs for the flippers and eventually landed on this leaf spring design. Because of the limited space of his print bed, the pinball table is printed in multiple pieces and then joined together using these 3D printed threaded nuts and bolts. This design also informs the playfield. To keep everything as modular as possible, the playfield is a grid of these threaded holes that can be used to attach various features, or can be threaded in from the bottom so the holes don't disrupt the ball's rolling. What's really impressive is this entirely 3D printed mechanical scoring system. There's a Kickstarter for the project to get access to the 3D printed design files if you want to make your own. And finally, you have to see this cinematic recreation of Star Wars Episode 4, A New Hope, created entirely from cardboard by Zach King. cardboard starships, cardboard costumes, cardboard sets. There's no process shown here, just the final film, but it's an impressive amount of dedication to the process that leans into its own sense of humor. This is more hardware wars than industrial light and magic, but it's a fun and loving tribute to a classic film. Check it out. Now for a few tips and tools. Angus from Maker's Muse is delving deeper into his designs for all 3D printed combat robots. And in this video he shares his techniques and slicer settings for printing nearly indestructible parts in just PLA. Part of his technique involves not just printing with a 100% infill, but looping the overall shape by printing the interior of the print as a large number of walls. But exploiting a few settings in Orca Slicer, he's able to offset the infill pattern of the walls, reducing the amount of voids in the part and increasing its overall strength. If you've used servos in a project, you know that for all they offer in terms of repeatable motion and reliability, they disappoint in one significant way: the sound that they make. They're noisy, and the telltale high-pitched squeal is really distracting. Who better than Will Cogley, maker of high-end animatronics, to try and find the quietest servo you can buy? Since the noise is largely a product of all the gear interactions with a servo, there is only so much you can do, though some manufacturers do manage to shave a few decibels off. The big reveal here is that the overall structure that the servo is mounted to can act as a resonant amplifier. He's able to reduce the noise from the servo by adding some sound damping to the mounting points. Bob from Duct Tapers Anonymous shares his design that he calls the Repair Box. This is a custom toolkit that he brings to repair cafe events in his city. He's repurposed an old toolbox with a lot of careful consideration and 3D printed mountings to keep all of his most used tools close at hand. A drill, various drill bits, a multi-bit screwdriver, and a soldering setup. There's an outboard holster for various pliers and grips, but I think my favorite part is this integrated articulating lamp so that he can have consistent lighting for his work no matter where he is. And Henrique Ferrolho has a video about how he turned this inexpensive time-of-flight sensor into a 3D scanner. Time-of-flight sensors are super inexpensive LiDAR sensors that can only detect distance, typically on a single axis. For this project, he's used in a recent development in these sensors that splits the sensor into an 8x8 grid. Not only do you get a wonderful primer on how to use the data from a sensor like this, you also get to learn how to pair it with an IMU sensor and some software to get a full 3D depth map of a space. It's cool stuff. For this week's DigiKey Spotlight, we have a video from their Another Teaching Moment series, and it's all about how to choose the right Mosfet for your project. Mosfets work a little like transistors and a little like relays. They function like a switch when receiving a low voltage signal, but can be used to turn higher voltage functions on and off, making them ideal for controlling heavier loads like lighting or motors. DigiKey has a separate video on how Mosfets work, but this video will help you choose which one is right for you. Check it out. All right, and that is going to do it for this week's show. A reminder, as always, that you can learn more about every single one of these projects by following the links down in the description. While you're there, leave us a comment, give us a thumbs up, and hit subscribe so you don't miss the next one. Great big thanks to DigiKey for making this show possible, and to you for watching. Take care. We'll see you soon.